Okay, everyone, so for this first problem, we have the word Mississippi, and we want to know how many permutations are there of the letters in the word Mississippi such that each permutation produces a new word. So, let's see. Well, we have 11 slots of letters. 6, 7, 8, 9, 10, 11. A slot for each letter. So let's see how many of each letters we have. Well, we have 4 letters S, we have 4 letters I, we have 2 P's, and we have 1 M. So out of these 11 slots, we want to select 4 to place the letters S into. So one such assignment could be S here, S here, S here, and S here. But how many such assignments are there? Well, we have 11 slots, and we need to select four of them to place the letter S into. Now, once such an assignment is picked, we now have 7 slots, and out of the 7, we need to select 4 to place the letters I into. So one such assignment could be an I here, an I here, one I at the end here, one I at the end here. So now we have 3 slots left, and out of these 3 we need to select 2 to place the letter P into. So one such assignment is P here and P here, and once these assignments are done, the location of the letter M is fixed. M has no choice but to go here. So this is the number of these unique permutations. Now, another way to approach this same problem is to say, okay, let's consider all the possible permutations of these letters, disregarding the fact that some of these permutations produce the same word. So, for example, if I took these 2 letters S that are next to each other and permuted them, I still get the word Mississippi. So that permutation doesn't produce anything new. Ideally, I don't want to count that. But for now, let's assume we take all the possible permutations of letters. Well, since there are 11 letters, we have 11 factorial permutations. Well, one of these 11 factorial permutations is this one here, the one we've considered. Let's give this a name. Let's call it P. Well, notice that for P, there are some permutations of P itself that leave P unchanged. For example, if we permute the letters S amongst themselves, then we still get permutation P. It doesn't change. So for each such permutation of letters S, if we then permuted the letters I amongst themselves, then the permutation P still remains unchanged. And then for every one of those permutations of the letters I, if we were to permute the letters P amongst themselves, we still leave P unchanged. So for this given P, how many permutations are there that leave it unchanged? Well, let's see. Well, we had 4 factorial permutations of the letters S amongst themselves. For each of those, we had 4 factorial permutations of the letters I amongst themselves. For each of those, we had 2 factorial permutations of letters P amongst themselves. Now notice that P is an arbitrary permutation of the letters of the word Mississippi. So for any permutation of the letters in the word Mississippi, we have exactly this many permutations that leave it unchanged. So if we take all possible permutations of Mississippi, all 11 factorial, for each one of them, we have this many permutations that leave it unchanged. So if we factor those out, then we are left with the number of unique permutations. Each permutation is unique. And now these 2 numbers are the same.